Welcome you all to this new course what we have introduced in NPTEL, that is nanotechnology in agriculture. So the first question arises, why and what is the philosophy of having a course like this? Of course, it's a pretty popular thing. Currently there is enormous interest in nanoscience and nanotechnology for various applications in our society, starting from medical to energy to agriculture to water purification and several other applications. But the question is it just because there are a lot of applications we are offering a course like that, or there is a philosophy behind this course, or where it all started? So this journey with you all will be a journey of philosophizing the subject, understanding the basic premise, and realizing that unknowingly or maybe knowingly we have been following traditional agricultural practices over the years, which are setting the paradigm for modern nanotechnology research for agricultural application. Just to give you a couple of examples, almost 30 years back, while I was in my first year undergraduate student in agricultural sciences, I used to observe something which all of you must have seen while traveling during the winter months. Especially if you are from northern part of the country, you must have seen it very frequently, that after the Kharif season, which is the rainy season, which is the currently, when I am recording this, it's a rainy season going on, and all over the place, whether it is down south or up north, the paddy fields, people will be sowing paddy, transplanting paddy. After this season is over, which is 90 days down the line, August, September, October, once we reach November and December, especially during that time, you will see, or maybe that time, or maybe after the next winter crop, you will see people burn the crop residues. So whatever you harvest the stuff and you burn it, and it's a tremendous problem in the northern part of India, where because of the burning, the smoke creates a lot of issues in terms of fog and everything. And apparently there are a ban also that you cannot burn so much of it. But the point is not that. Point is, what is this burning? So if you look in these crop fields, you will see half-burned residues of crops, kind of partly charred. And once they are partly charred, what a farmer does is they again plow the land and mix those charred stuff into the soil. Of course, a farmer will say that traditionally this is how we increase the organic matter of the soil, and this is how we make the soil rich. But on the other hand, with the modern nanotechnology research, if you look at it, what they are essentially doing, when you are burning something, you are converting a biomass. So it's basically a crop residue, which is a biomass, right? A biomass is nothing but carbon, hydrogen, oxygen, nitrogen, handful of elements which constitute the biomass, the major chunk of the biomass. So while you are burning, you are leaving behind a burnt carbon residue in the soil. Now when we talk about a burnt carbon residue, So we are talking about, from the nanotechnology perspective, we are talking about real carbon, where you have heard about carbon nanoparticles, carbon nanotubes. If you go a little bit advanced, then graphene-like structure, carbon quantum dots, and all these things. Now the question arises whether our ancestors were aware of it or not. We do not know. We cannot go back in time to figure that out. But essentially, what they were doing is they were enriching their soil with carbon particles, which is of course organic matter. But then when you are enriching a soil like with such carbon, what is the benefit? What it does? So in other words, if you think of it, that carbon which is added back to the soil is now at a much more smaller dimension. It is no more a huge biomass kind of stuff, and the availability of such carbon to the plant will be much more higher, or such carbon along with other things can form compact structures which may be helpful for storing nutrients of the soil, or that may help to purify the water, or that may be able to chelate some of the nutrients which plant will be needing. They may be acting as a slow releasing gel after mixing with the clay of the soil. There are empty number of possibilities which may arise out of it. This is one example. So this is 30 years back. I, as a young student, believed, oh wow, this is a good idea to increase carbon. But then today, while I am teaching a course in this area, I kind of look back to my own journey and see, wow, it means somebody thought it out. I don't know who are they. Our ancestors who realize it works. So to say that nanotechnology is a very new branch, yes, indeed, man has rediscovered in its effort of understanding or going down to the level of atoms, molecules, small number of molecules in a cluster, calling nanoparticles, or arranging them in a self-assembly, calling nanotubes, or arranging them in a certain bonding symmetry, calling them graphenes. But our ancestors, maybe knowingly or unknowingly, have been using it. Next example, what I wanted to highlight with you is, you will hear this pretty frequently, that you add organic matter into the soil to a certain amount before you start the cropping season, and that will increase the availability of nutrients, that will increase the microbial activity of the soil. Now when we talk about organic matter adding to the soil, what does that essentially means? Again, going back by my undergraduate training, for us, we really never thought beyond it what it is doing. But in the light of the modern research, it looks like organic matter, which is nothing but carbon, different kind of carbohydrates, different kind of multi-chain polymers, natural polymers, which are mixed together and put into the soil. They are just like a mesh where things get trapped. In other words, when you talk about slow releasing gel, you all have heard this word. There are gels which are slow releasing the drug, or some kind of encapsulated, like a capsule. It's almost like these are capsules in the soil which are trapping several things. So they are acting like a mesh network from where slow releasing the different nutrients all over the place. Not only that, such structures can even help to modulate or balance the pH of the soil. So now the question arises, when we talk about nano carriers or nano gels. These are the interesting buzzwords which are slowly populating the literature. Or, as a matter of fact, in the field of agriculture, there is another interesting aspect which is slowly taking the central stage, is precision agriculture. I'll come to that aspect. But all these things, if you look from a perspective, just if we pull ourselves back and look at it, you'll realize by simple wisdom of mankind through the ages, through centuries and millennia, we have acquired this wisdom, and that has what led to today's modern agriculture. With the advent of nanotechnology, I will say we are realizing or appreciating some of the naturally acquired wisdom of our ancestors. So, I gave you two simple examples. One is of burned carbon, the other one is of organic matter addition into the soil. For me, today, 30 years later, after completion or after starting my undergrad training back in '89, I will say that I'm rediscovering myself, what I have read, and this journey will be with you people this time, rediscovering agriculture in the light of modern research in nanotechnology, realizing the wisdom of our ancestors, realizing how they did certain practices they may not have or had the privilege of seeing these particles under high resolution transmission electron microscopy, which are one of the tools we'll be using, scanning electron microscopy, or X-ray photoelectron spectroscopy, or atomic force microscopy, or they did not have the tool to measure the surface area using BET or using other techniques. They never had the tools to understand or evaluate the porosity of the particles. Yet, by sheer trial and error, through the ages, they fine-tune the techniques. And what we are doing, I just left you a few minutes back with a word called precision agriculture. I'll come to that. Now, precision agriculture is essentially telling that how precisely we can apply nutrient to an individual plant so that it consumes that and rest what we do. Say for example, when you talk about a field, we spray, but between two plants there are certain things which go waste, which is never utilized, unutilized. So precision agriculture in a very simplistic sense is you are ensuring an individual plant gets that much what it is needed. In other words, it is almost like personalizing the plants or personalizing the crop. Okay.